Hey there everyone, and welcome to another video. This video, you're not really going to be able to hear what I'm going to show you guys, but you will see it, and I'll explain what it does. So we're in a terminal right now, and I'm going to zoom us in a lot. You know what, it's probably better if I just zoom in using the magnifier, because if I set the font size high enough to be able to see it, I can't fit anything on screen. But in this terminal, what I have is a program I wrote. I actually wrote a USB driver for my headset. Now, it's not a complete driver, it only has one feature, and it's the ability to turn one little toggle switch on the headset on and off through the command line. But it is so incredibly helpful for me that I wanted to show it to you guys and how I built it. And this is a program called Mic Monitor. The reason it's named Mic Monitor is it comes from the fact that I have a HyperX Cloud Alpha headset. That's where the hyper comes from. And mic monitoring is a feature on that headset, which other gaming headsets might call side tone, some of them might call side chain. Whatever they call it, it's all the same feature. What it does is it takes the input from the microphone, so me talking, or typing, or whatever, and plays it back through the headset in hardware. It does it in hardware so that there's no latency. And a feature like this is very useful when you're in, for example, a voice chat, because when you have the headset on and you're talking and the mic monitoring isn't on, a lot of these headsets are padded very well and you can barely hear your surroundings. But in a voice chat, you're talking, and I don't know about you, but for me, it's very difficult to speak when I can barely hear myself speak. So the mic monitoring helps out a lot with that, in general. But I don't do voice chats often. What I do way more often is programming, and that involves typing, right? And typing, for me, being blind, is very difficult. I can do it, but it took years of practice. I type my own way, and what makes me fast is the fact that I have 3 different ways of being confident that I'm actually typing properly. First one's obviously visual, which is why I'm zoomed in so much. You know, if I type in Mic Monitor here, I can tell that I'm typing in Mic Monitor, because I can read it. I struggle. The other cue that I have is tactile. I have clicky, loud switches. I have a mechanical keyboard with cherry blue switches, and that's not because I like to be an asshole in a voice chat and ear rape everyone with the clicky switches. It's because I physically need that tactile sensation of the switch clicking. Other keyboard types I just cannot get up to speed with. And then the other cue that I have is audible. I need to hear it. Otherwise, I can't keep speed. So mic monitoring helps because it amplifies the sound of my typing even when I'm listening to music. And it makes me a lot more confident. So this program is really simple. If you just run it with no arguments, it's going to put out a little blurb about what it does. Basically, it tells you how to use it. It's really simple. You just put true or false for the command line arguments. And all it does is it turns on and off mic monitoring on this specific... I have to update this. This does not use libUSB anymore. It uses HidApi, but anyway, that's for later. It basically talks to your USB receiver for the HyperX Cloud Alpha Wireless headset and tells it to turn on and off mic monitoring, which is something you can ordinarily only do in HyperX Enginuity, which is a shady, bloated UWP application you get from the Microsoft Store that drops the frame rate of your desktop even on a 7600 XT to below 10 when it's open. I don't know why, but yeah. The point is, it only runs on Windows, and I'm on Linux. And it was one of the reasons I needed to stay on Windows for a while, because I need that feature. But anyway, if I do Mic Monitoring, or Mic Monitor false, you don't hear it. But I definitely do. My headset beeped twice, and now I can barely hear my own voice. Mic monitoring is now off. If I do true, then the headset beeps again, and I can hear myself. because mic monitoring is turned on. So it's a simple little program. It's very easy to use. But how did I make it? Because I'm not a HyperX developer. I don't work there. I don't know how the hell these headsets work. I'm not a USB person. I'm a game developer. Well, it's because I reverse engineered it. Basically what I decided to do, now I won't be able to show this because I don't have the Windows system, but on Windows, if you have Wireshark, which, you know, a lot of my friends and I are very familiar with because of Little Big Planet, you can download a program called USB PCAP and set it up to work with Wireshark. And then what you can do is you can use it to capture all USB input and output going through your system on a specific root hub. Now I know what root hub my headset is plugged into. It's the one that my front panel USB ports are on. And USB PCAP can actually let you identify which hub everything's plugged into. So I was able to find that. And then I used Wireshark to take 3 packet captures of me turning on and off the mic monitoring feature inside HyperX Enginuity. And what I noticed is every time I turned it on, 4 packets would get sent. 2 of the packets were, I guess, some low-level system stuff that isn't, like, important to me, but there were 2 other packets. One got sent from the host to the USB device, and it sent a 96-byte packet. I believe it was sending 4 bytes that weren't 0, and they were 0x21BB1001. I don't know what the 21BB10 means, but I assume what it means is mic monitoring, and then the very next byte is turn it on, 01. And then I noticed that the headset would immediately reply back with that. And I took another packet capture and did the same thing. And interestingly, that time, the toggle switch in the UI had actually reverted back to being off. And what I noticed in the packet captures is when that happened, the headset actually didn't return that same 21BB1001 that I expected. It returned something completely different, and I guess it was confusing the headset's driver, and it just went, okay, something went wrong, I'm going to revert the toggle. But then I took a 3rd packet capture, and this was me turning on and off the toggle 5 times. And I noticed, well, I turned it on 3 times, and that 21BB1001 packet showed up 3 times coming from the host, and 3 more times coming from the headset. But then 2 times, I saw 0x21BV1000 show up from the host, and then 2 more times from the headset. And that corresponded to the 2 times that I had turned off the toggle. So that gave me everything I needed to know. So then, I started asking around about how I could actually replay those packets, how I could send them to the headset receiver. And, long story short, it became, we go into projects, outline under, Hyper Mic Monitor, and we go Hyper Mic Monitor, it's written in C#, we go program.cs, it became this program. So, first thing we do is we import HidApi. It's a package you can get for .NET. Yes, there is a HidApi wrapper for .NET. How crazy a world we live in, that the program language that used to be used to write ancient, crappy business software in WinForms and, like, intranet applications in ASP.NET is now used to used to write USB drivers and game engines. It's amazing. I love C#. But anyway, so, you know, namespace Hyper Mic Monitor. The very first thing that we do is we figure out the product ID and vendor ID of the actual USB device. And in this case, the vendor ID is 0x03F0, and this is something you can find out through Windows Device Manager. And then the product ID is 0x098D, and that identifies the USB receiver for my headset. This timeout variable is actually unused. We don't need it anymore. This is when I was using libUSB, and it was very finicky with the timeout value, and I set it to 3 seconds. But anyway, once we get to this public static void main string args, this is not Java, I promise. You can tell it's not Java because the string is lowercase, but anyway. We do some argument parsing to figure out what we want the actual setting to be, and then it's just like, do we have one argument? If not, print the usage string. Is it a Boolean value? If not, print the usage string and exit. And then we take that Boolean value and we send it to set mic monitoring and pass it the bool value. So if we scroll down, we can actually look at what this set mic monitoring thing does. Right here, public static void set mic monitoring bool turn on. What we do is first we grab the device info based on the vendor and product IDs by doing hid.enumerate and passing vendor ID and product ID and getting the first or default. This is why I really like C#, because technically you could have multiple USB devices with the same vendor ID and product ID. I don't know why you would have multiple HyperX Cloud Alpha headsets plugged in specifically. Maybe you're doing some multiplayer thing and doing something really weird to have multiple players on the same computer. I don't know. But either way, it's possible, and, you know, this allows me to get the first one. So it does mean that you can only have one plugged in, and I can't guarantee which one it will grab first if you have multiple. But the first or default means that if there is none, you'll get null. So, if we get null, then we can say, hey, your headset isn't plugged in, we couldn't find it, you might want to plug it in first. So that's great. And then, if we don't get null, then we say, hey, we found it. This is the manufacturer, HP Inc., and this is the product string, HyperX Cloud Alpha Wireless. Awesome. So then we try to connect to the device. And this is where I don't like the HidApi.NET API. Because what I had to do here is I needed to declare the devices, or the connection as null, and as nullable, and then I had to try to connect to the device, because if you try to connect to a device on Linux and you don't have the permissions, you'll just core dump. You can't stop it. It's gonna core dump. There's no try connect, there's no, like, return null if it didn't connect, or return an error if it didn't connect. You have to try to connect, see if it crashes, and if not, you log it to the console and you gracefully exit. Otherwise, you will core dump, and it's not fun. But anyway, once we actually get this connection, which, if you have the correct permissions, running as root, or you have the correct udev rules, which I do, which I'll show you guys how to set up later, you get this connection variable. And then it's really simple. All we have to do is declare some kind of buffer. In this case, I allocate it on the stack. I allocate 96 bytes, and then I fill 4 of them in. The first 3 being the 21BB10 that the headset expects from the packet captures. And then the next byte I fill in is, if turn on is true, I fill in a 1, and if not, I fill in a 0. And then I send it to the headset. And then I log whether mic monitoring has been turned on or off. Pretty simple. And then I close the connection, and I exit the program. So it's really not that complicated. I thought that this would require C or Rust or something really low level. I thought it would require hundreds of lines of code just to find the USB device. I thought I'd have to write a kernel driver. I thought I'd have to do all this complex crap. But no, I can do it in C#, and it works flawlessly. So let me show you guys how to set it up. Alright? So, all you have to do to build it, and I will eventually have this be an AUR package, the very first thing you want to do is in the root of the repository. First of all, the repository you can get from cloning the repository at acidiclight/hypermicmonitor on GitHub. But once you get the repository, the very first thing you're going to do is you're going to do an ls, and you're going to see this .rules file. This 70 hypermicmonitor HID.rules. This is a udev rules file, and if you're on Linux, you need it. Otherwise, you'll only be able to run the program as root, and that's probably not ideal. So what you're going to do with this file is you're going to take it, and you're going to copy it as root, sudo cp 70 HyperMic Monitor HidApi.rules. You're going to copy it into /etc /udev /rules.d /70 HyperMic Monitor HidApi.rules. And the reason it auto-completed is because I've already done this, otherwise the program wouldn't be working. But once you do that, you're going to need to find some way to reload the udev rules. The most reliable way I know of is to reboot your computer. Honestly, it's fine, just reboot, everything's going to be fine. Anyone who says you don't need to reboot Linux is lying, so, you know, it's probably a good idea to reboot anyway. So once you've done that, then what you can do is you can .NET publish it, and I publish it to /opt. So I already have a /opt /HyperMic Monitor folder, but if I go back to projects, Alkaline Thunder, HyperMic Monitor, what you do is you do sudo .NET publish -- self-contained -r for runtime ID, Linux x64, replace x64 with whatever architecture you run on. It's gonna depend. And I don't know what architectures.net supports, and I don't know what the RTIDs for them are, so you're gonna have to find that out on yourself. I'm assuming if you're in this level of weeds, you know what you're doing. But in my case, it's gonna be x64 because I'm on a 64-bit x86 64 system. And then you're gonna do -o /opt /HyperMic Monitor. And this is going to build the .NET project as a self-contained .NET application, which means you're going to have a copy of .NET sitting in that OPT folder, which is fine. But what this also means is you can run it as a standard Linux binary at /opt /HyperMic Monitor /HyperMic Monitor, and it's going to run the program. It's going to be nice and fast too. And then if you want it in your path, what I do is I symlink from /usr/bin /HyperMic Monitor, ls-la-rt /usr/bin grep HyperMic Monitor. You're gonna see that symlinks over to opt /HyperMic Monitor /HyperMic Monitor, and then that lets you just run it as a command in your shell, and it just works. And then, like I said earlier, you pass true to turn it on, you pass false to turn it off, and then you immediately pass true to turn it on because I want to be able to hear myself talk. So great. Awesome. So yeah, I'm going to eventually package this on the AUR, so the ARC users out there, by the way, will be able to go and do yay-s HyperMic Monitor, right? And it'll build the package, it'll put the udev rules in the right place, do whatever it needs to reload them so it's nice and seamless, and you just do HyperMic Monitor true, and as long as you have the same headset I do, it'll work. So yeah, I just wanted to tell you guys this little program I wrote. It's nothing too extravagant, it's not socially distant, but it's gonna really help me with accessibility on Linux, and I'm really proud of myself. So yeah, I hope you enjoyed it, and I hope you learned something about USB and HID, which, by the way, stands for Human Interface Device. But anyway, as always, I'm Michael, even though everyone calls me Ritchie. Hope you enjoyed the video. If you like what I do, a subscription would be great, and if you'd like to support what I do, there's the Patreon link in the description below. That's gonna do it for this video. I'll see you guys in the next one. And, you know, I think the next driver I might write is for the Stream Deck, because this is getting kind of annoying.